This is a brief presentation highlighting some of the unconventional play characterization tools RISC Advisory are using in their assessment of global unconventional opportunities. The techniques can be used in pervasive unconventional systems such as coal seam gas, tight gas and oil, and shale gas and oil plays. My name is Ian Cockerell and I'm Head of Geoscience for the RISC Advisory Group. RISC has completed over 2,000 assignments across the world in more than 70 countries, and in line with the industry over the last 10 years, we've supported our clients on an ever-increasing number of unconventional assets. RISC expertise can be found throughout the unconventional lifecycle, from basin-level opportunity screening and play characterization, right through to reservoir and production management of your unconventional assets. This map, courtesy of the EIA, provides us with a useful starting point to discuss global unconventional opportunities. Of course, we can recognise there is a phenomenal amount of unconventional potential outside of North America. However, during this period of sustained lower oil prices, the development of unconventional plays outside of North America is undoubtedly challenging. I've now colour-coded the map based on observations of when those basins become, or at least became in the past, commercially interesting. So at what oil price did we really start to hear people talking about these particular basins with regard to their unconventional potential? This of course is somewhat subjective, and we can certainly recognise some niche areas globally where there could be exceptions to this, but it's quite clear, and not really surprising, that outside of a select number of systems in North America and a handful more in different parts of the world, the majority of these opportunities don't gain real commercial interest and traction at oil prices less than $80. What we've also recognised over the last few years, of course, is that certainly 4 or 5 of the North American systems are not only healthy, but even commercially robust under a $60 oil environment, and some of the sweeter spots of those basins being robust at $40 oil. What this map starts to give on a macro scale is an impression of where the global unconventional sweet spots are, and of course the principal drivers behind those sweet spots are a supportive business environment and access to market and infrastructure. In Australia, we can see some of those challenges that face global unconventional opportunities. If we quickly start to stack those key ingredients of a successful unconventional opportunity together, it all has to start with the geology, of course, but on top of that, we need a supportive business environment, something we've started to see tested in various states and provinces of Australia in more recent times. And Australia also has challenges with remoteness to market and lack of infrastructure, again making commercially robust unconventional opportunities more challenging, particularly in a price environment closer to $50 oil than $100 oil. We can stack these elements up and start to focus in on areas for unconventional opportunities which make more commercial sense. We can take those principles and go to the other end member of sweet spot mapping, in areas where we have rich datasets of unconventional well data and production. This is an example from the Montney play in Canada, where an extensive digital well database of over 1,800 wells was used to identify sweet spots of production in the play and then quantify the resource by calibration to known production, using an approach we call common recovery segment mapping. The approach uses a disciplined method of identifying key play components of the unconventional play of interest and mapping the individual components spatially using zone attribute calculations. A spatial analysis approach on the key characteristics ultimately leads us to the quantification of the plays. So let's look at the sweet spot mapping methodology. The producing North American plays are blessed with huge amounts of well log and production data. We can of course study those wells and their associated production to recognise particular characteristics and identify the key attributes of the play. By looking at the high quality producing wells, we can start to recognise particular characteristics of those zones. The key characteristics are identified, mapped individually and stacked together, providing us with a common risk segment map or a sweet spot map, which at this point is a qualitative representation of quality and potential for the mapped zone of interest. We can now go back to our production data and have a look at how the wells in each one of our common risk segment mapping cells relates to production. We can look at the relative importance of individual attributes and begin to make assumptions on what factors are contributing to the production results and to what extent. We can begin to add a quantification element to our understanding by calibrating the common risk segment map to production. So for example, if well A produces 7 BCF of gas and 200,000 barrels of liquids, then we could expect all of the cells with the same colour or value of that at well A to have the potential to produce 7 BCF of gas and 200 barrels of liquids, as they have comparative geological characteristics. Based on the individual component mapping, we now have attribute data of key geological characteristics behind every cell. And furthermore, we have a calculation which rolls up all of those attributes to give us our common recovery segment map, which is a relative performance indicator against key producing calibration wells. From the common recovery segment map, we can begin to build up to an understanding of ultimate recovery for each unit. From the production data, we can map out across the basin a liquids to gas ratio. By multiplying the liquids to gas ratio map with our production calibrated common recovery segment map, we can produce maps of gas and liquids potential per well. These maps are an interpretation of what one well in a section will produce from an individual unit based on how the geology of that area differs from known production. We can now look at zone pay thickness. That's the potential number of frac envelopes per zone. Here we go back to our net pay mapping and instill a series of cutoffs for where we recognise pay based on the known production in the zone. This is also where we start to fold in our anticipated lateral drilling density. We normalise our development scenario across the entire area based on current well development densities. By normalising the development, this allows us to look at the play purely from a geological point of view, allowing us to identify the sweetest spots and then quantify them in terms of potential. By multiplying our potential wells per zone maps with the gas and liquids potential per well maps, we produce maps for each zone on gas EUR and liquids EUR for the entire play. So one of the key products we get out of this is a section by section quantification of estimated ultimate recovery across the entire unconventional play fairway, in this case the Montney play in Canada. Each section here has attributes behind it linked to the geological characteristics of that cell, allowing us to describe the play and quantify the play in unprecedented detail. This work has been brought together to produce the Montney Play Atlas, one of a series of products RISC is undertaking in describing and quantifying the major North American unconventional plays. In addition to the maps, the product also comes with all of the petrophysical interpreted well logs hyperlinked to each map, allowing us to click on wells of interest around the basin and ensure the mapping remains consistent with the well data. We can also look at the held acreage positions over the plays and spatially join the acreage maps to our EUR interpretations to look at what individual companies are holding in terms of liquids EUR and gas EUR potential in their respective positions. And so for the Montney, for example, this is a histogram of companies' disclosed acreage spatially joined to our interpreted EUR calculations. For asset evaluations, the Atlas allows us to search on specific companies or areas and directly get an estimate of that company or that area's estimated ultimate recovery potential. Moving further down the process, our spatial analysis workflow can now help us in development planning. Each planned horizontal location is directly linked to the underlying attributes, including the estimated ultimate recovery on each section. That provides a value for each location and allows us to switch on and off locations dependent to oil or gas prices. So our understanding of recovery in the field is intimately linked with the development, which is of course subject to the price environment. So in the example provided here, the Upper Montney in this section of land has 94 commercial locations identified at an oil price of $75 versus 7 commercial locations identified at an oil price of $55. Because of the underlying EUR framework, we're being able to plan developments and locations in different price scenarios. So whether you're in a coal seam gas, a tight oil or gas, or shale oil or gas opportunity, our basin analysis and sweet spot mapping workflows can support you in de-risking your project. From basin level opportunity screening and play characterization right through to reservoir and production management, RISC has the experience to support you. From exploration strategy all the way through to marketing, RISC provides the highest level of technical, commercial and strategic advice across the value chain. For more information, please check our website. And with any specific questions on our geoscience work in unconventional play analysis, please feel free to contact me at ian.cockrell@riscadvisory.com. Thank you.